Hi, in this problem here, we've got two equations, linear in fact, and we're asked to find the solutions for x and y which satisfies both these equations. Linear equations can be represented by this equation y is equal to mx plus c. And you can see very clearly that the equations that are given in the problem are not in this format. The first thing to do is rearrange this in this format. So equation 1 is going to be 6 plus 9x minus 3y equals 0. You can rewrite that as minus 3y equals minus 9x minus 6. And you divide by minus throughout, so it becomes 3y equals 9x plus 6, or y equals 9x plus 6 divided by 3. So that's the equation 1 as a function of x by keeping the y on the left hand side. The second equation is 1 upon 3y minus 2 upon 5x equals 3. To do that, we can write this as y upon 3 equals 2 upon 5x plus 3, or y equals, by multiplying both sides by 3, so I can write 3. So we're going to have two quantities inside the brackets, so it's good to use the bracket notations. So it's going to be 2 upon 5x plus 3, which when simplified becomes 6x upon 5 plus 9. So that's the second equation. Okay, so we've got two equations which we have written in the form of y is equal to mx plus c. So wherever there is y, we can use 6x upon 5 plus 9. So let's do that. So I can write 9x plus 6 divided by 3 equals 6x upon 5 plus 9. So we've got now one equation with x as a variable. So it's just a matter of rearranging this equation and solving for the value of x. So 9x plus 6 equals 3 times 6x plus 9, which is same as 18x plus 5 plus 27. And I can write this further as, or 9x minus 18x upon 5 equals 27 minus 6, or by taking the LCM on the left hand side, which is going to be 5, so it will be 45x minus 18x equals 21. So it's on the left hand side, it's going to be 27x upon 5 equals 21, or x equals 21 times 5 divided by 27, which is same as 105 upon 27, or 35 upon 9. So that's the value of x. To calculate the value of y, so we can substitute the value of x in any of those equations which involved y. So we had earlier an equation for y as 6 plus 9x equals 3y. So here I can substitute for the value of x. So let's do that. 6 plus 9 times 35 upon 9 equals 3y. That means 6 plus 35 equals 3y, or y equals 41 upon 3. So now we've got two solutions. X is equal to 35 upon 9 and y is equal to 41 upon 3, and is usually written like this: x and y coordinates separated by a comma and in a bracket. So this is one of the ways of doing the problem, but we are asked to calculate a second way of doing the same problem. So that is by doing a graph, because two lines, when they meet, the intersection point are these 2 points. So we've got the equations, two equations, we have rearranged it. So let's go to Excel and we can plot these two equations. So that was the first equation, so which we said y is equal to 6 plus 9x upon 3, And then the second one rearranged like this. So I can give random values of x, and then I can calculate the values of y, and I can plot this in Excel, and I can see that there is an intersection point, and which pretty much resembles what we have calculated earlier as 35 upon 9 and 41 upon 3. What we have, so two different ways of solving two linear equations, either algebraically or graphically using Excel. But I don't think in the exam you will have Excel, but you will have a graph paper. But as long as you know how to get the value of y for any given value of x, because you just need two data points to make a straight line. So then you can take a ruler, extend the data points, and where there is an intersection, the intersecting point is your solution.